Hello and welcome to today's webinar and dialogue entitled Advanced Materials for Strategic Sectors. It's great to have you here today for what I think is a really exciting program. We have some wonderful experts to weigh in on this topic. Thanks for joining the OECD Global Forum on Technology Dialogue. I'm David Winikoff. I help lead work on emerging technologies in OECD and the Director for Science, Technology, and Innovation, and the OECD lead on the Global Forum on Technology. The objectives here, this is part of a dialogue series and actually a horizon scanning exercise itself to help policymakers understand emerging developments before they become difficult to influence. We'll be having a simple progression of understanding what's happening, why does it matter, and what should governments do about it. But to further introduce this event, I wanted to present Jerry Sheehan, the director of the OECD Directorate for Science, Technology, and Innovation, for some opening remarks. Jerry?
Yeah, thank you, David. And let me say good afternoon to everyone who's joined us here today. I'll join David in welcoming you to this dialogue on advanced materials that is convened under the OECD's Global Forum on Technology. As David mentioned, today's discussion is part of the so-called GFTech's Horizon Scanning track, which is exploring emerging technological developments and as well as their policy implications. In an increasingly digital environment, it's often easy to overlook the technological revolutions that are occurring right here in the physical world as well. Advanced materials, by which we mean those materials that are designed or engineered to have enhanced properties, are transforming their products, industries, and they'll transform our societies as well. And they do this in a number of ways. They can increase product performance. They can provide new functionality, improve sustainability, in a number of different areas, ranging from semiconductors to energy systems to healthcare and manufacturing, communications, aerospace, and the list goes on to many, many other strategic sectors. We find as well, and we'll discuss in today's event as well, how advanced materials are foundational inputs for many emerging and strategic technologies, which are also often discussed here in the GFTech. They're an important factor in how products perform, how efficiently they operate, how long they last, how safely they function, and how sustainably they can be produced, used, and recycled over their lifetimes. So just to give a few examples, new battery chemistry, for example, can help reduce reliance on scarce inputs while improving battery storage capacities. Advanced composite materials, we already see making aircraft and other vehicles lighter and therefore more energy efficient. New biomaterials can support more targeted drug delivery and more durable medical implants. So you can see opportunities across a range of different product and industry sectors. As countries then are seeking to strengthen their competitiveness, improve their productivity, build greater resilience, the importance of these innovative materials is increasingly apparent. They're helping diversify critical raw material supply chains. They're strengthening domestic manufacturing and processing. They can support recycling and development of more circularity in our economies, and they can also help reduce vulnerabilities in highly concentrated supply chains, including for a number of emerging technologies and strategic sectors. And this applies not least to some of the strategically important areas. Again, semiconductors, biotechnologies, which are discussed here in the GFTech, battery technologies, clean energy technology, space systems as well. In all of these areas, materials innovation is increasingly underpinning economic competitiveness and technological leadership. Issues around economic security are becoming more prevalent, and we see from this perspective that materials innovation can help reduce specific dependencies. So, for example, developing battery materials that use less cobalt or nickel, or semiconductor materials that can reduce exposure to concentrated supply chains. At the same time, processes supporting materials innovation themselves are changing. We see new scientific advances converging with developments in AI, high-performance computing, simulation, and automation. And all of these together are transforming how materials are discovered, how they're manufactured. It's accelerating innovation, improving resource efficiency, and really unlocking entirely new capabilities. We see researchers using AI and simulation technologies, for example, to better screen thousands of possible material combinations before entering the laboratory, better predicting their properties, their conductivity, their durability, and this allows them to test candidates much more quickly. All of this can shorten discovery cycles and reduce more costly trial and error. The acceleration we see is also reshaping global innovation landscapes in material science itself. If you will, the geography of innovation is becoming increasingly competitive, and technological and geopolitical developments are raising important questions for policymakers that we need to address. So this is where enabling the field of advanced materials, requiring not only scientific breakthroughs, but development of more innovation ecosystems that promote collaboration across and among researchers, those in industry, investors, regulators, as well as end users and consumers, whether those are individuals or companies as well. It's also going to require greater anticipation of opportunities and challenges that rely on tools that we rely on here in the GF Tech, like horizon scanning, like robust technology assessments. And here again, issues about cooperation across countries is not only important, it's essential to realizing the benefits of these technologies. So as I've said throughout my opening remarks here, these are precisely the kinds of issues that the OECD's Global Forum on Technology, the GF Tech, was created about 3 years ago now to explore. In the Global Forum, we bring together governments, experts, and other stakeholders to help us better anticipate emerging technologies, exchange perspectives, and help strengthen international and multi-stakeholder cooperation so we can advance their development in ways that will reflect our own economic and societal opportunities. So today's discussion is to come back as the first in a 4-part dialogue series. As I mentioned, that's under the Horizon Scanning track. It's building on our broader work at OECD on emerging technologies, on strategic intelligence, and on anticipatory governance. And it reflects the growing interest here at OECD and how advanced materials will reshape industries, promote industrial transformation, sustainability, and future competitiveness. So over the course of today's event, we're going to have the opportunity to hear from leading experts who will share their perspectives on technological trends, on some of the industrial applications, as well as on some of the policy and governance challenges that we need to address. The aim of these conversations is to help us better understand not only where advanced materials are heading, but what the policy choices are that we need to make now or soon in order to maximize their benefits as they continue to scale and while managing some of the associated risks and downsides. So I think we need to be aware of how new materials are going to impact people, how they impact our economies, how they'll impact the planet, how they can create new dependencies on scarce resources and specialized processing capacities, what their potential dual-use applications are in sensitive sectors, and how we can operate in an environment where the technology scales faster than standards, regulation, policymaking, or even public understanding. So I think in this respect, today's dialogue is a step toward helping us anticipate and respond to these issues in a collective, multi-stakeholder manner. I want to close by thanking all of you for joining us here today. I want to thank our team, the GF Tech here at the OECD, for organizing this event and the broader initiative of which this is part. And I want to wish you all an engaging and productive discussion today. With that, David, let me turn back over to you to guide us through the rest of today's event. Thank you again.
Thanks so much, Jerry, for setting the scene for this exciting event. We have a lot of aspects of these technologies to explore, but putting them also in a social and political context as well to better understand and, as Jerry said, anticipate where we're going. And we'll be doing some of that anticipation in this first panel. entitled Anticipating Frontiers in Advanced Materials. We have a number of excellent speakers with broad experience in different aspects of the technology, and we're going to ask them to look ahead at where we're going. What are some especially important trends in the technology, and how might those technologies and those trends relate to policy? We'll have a dedicated policy session later on today. We're going to ask what developments are emerging, where is the field heading, which trends should policymakers begin to pay attention to. I'll ask the speakers themselves to introduce themselves a bit, but just to let you know, we'll have Professor David Knowles, who's CEO of the Henry Royce Institute, the UK's National Institute for Advanced Material Research and Innovation, and Professor of Nuclear Engineering at the University of Bristol. We'll have Marie-Pierre Aperciel, who is the President and CEO of Prima Quebec, a cluster organization that supports advanced materials innovation and industrial collaboration across Quebec. And finally, Dr. Jed Pitera is a strategy co-lead for accelerated discovery in sustainable materials at IBM Research. We'll look forward to the speakers building on each other through the course of the panel. But I'd like to invite now our panelists to give some opening remarks, fairly brief on their background, their organization, and maybe one development they believe is currently reshaping advanced materials research, innovation, or industrial deployment. So could I ask David Knowles to kick us off?
Thanks very much, David, and it's great to be here. And I'll try and be brief. So I'm Dave Knowles. I'm the CEO of the Henry Royce Institute, which is an advanced materials institute based in the UK. We are funded down by government, and our remit really is to support looking at support to industry and academia in terms of translating particularly materials innovation, but also looking at foresighting and provision of capability and infrastructure. So we look after a lot of infrastructure for making, testing and characterizing materials. A big part of my focus over the last maybe 2 to 3 years has very much been a national materials innovation strategy, which we've produced in the UK, which has now been incorporated into the government's new UK industrial strategy. I'm careful with my words there. I know this is advanced materials, but I talk a lot about materials innovation because I see a lot of the sort of, if you like, activities that we're doing around innovating in how we use existing materials, sometimes around how we recycle them, or how we apply them. And so, it's all still advancements and innovations in the material space, but sometimes we can get very caught up with terminology in that regard. I'm sure other people are going to talk to a lot of exciting things that are coming forward. And so I'll put a bit of a dose of realism on things at the moment. I think, one of the really important things that we focused on as we were developing the strategy, of course, digital was one, but the other one was sustainability. And in that context, we really focused on sustainability in terms of how we were going to manage finite resources, really the global implications and how we were working and using materials. I would say that has evolved quite substantially in the last year, probably even more so in the last 9 months or so. We now very much talk about supply chain resilience. Now, you might argue that drives similar behaviors, but it's very much around how we manage supply chains in materials and materials manufacturing and how that translates into the economy. So that's, for me, a really important focus. That does look at diversities of supply chains. It looks at diversities in how we're using and applying materials. And that's something I think we may come back to and touch on a little bit more today, because it's really important from the UK's perspective. We don't have a manufacturing economy without a materials economy. And so, materials are absolutely essential to what we're doing nationally and internationally.
Thank you, David. A great way to kick us off. I want to turn now to you, Marie-Pierre, to take us on an initial journey. Go ahead. And you're muted, Marie.
I'm sorry. Thank you very much. My name is Marie-Pierre Hyperciel. I'm leading Prima Quebec, which is the Advanced Material Research and Innovation Hub based in Quebec, Canada, that support and facilitate the advanced material ecosystem by promotive, collaborative innovation. We received the mandate from the Quebec government. We are what we call a sectoral industrial research group, and we do rely on financial support from both the Quebec government for 65% and the rest from the private sector. In a nutshell, basically, our mandate is to foster research-industry relations through our expertise, but also through the grants that we can offer for when we support the government. But we do more. We do document, but also develop different insights on our ecosystem, trying to position our actors and players in Canada, but also abroad. A very small organization, and my team has the expertise in material science. I do second what David was mentioning, and what I believe is also important to insist on, which is crucial, would be the access to cutting edge equipment and expertise, especially for SMEs that don't have usually the money to buy those equipments nor have the expertise to run them. This is an important element we've been working on. So state-of-the-art platforms do not just provide advanced equipment. Their technicians or also the operators' specialized expertise is usually a critical safeguard against innovation failure. So saving organization vital time investment, but also resources while accelerating scientific outcomes. So eventually, I will also have my point of view on sustainability, which is very important. But finally, I do think that policymakers should also keep in mind this notion of equipment, for example, that will allow characterization, synthesis of advanced material, especially when it comes to supporting the acquisition of those equipment. We must not underestimate the importance of having the necessary human resources to keep them running. Otherwise, you do have a great car like a Mercedes, but no fuel, no drivers. So that would be my opening remarks.
Thanks so much, Marie-Pierre. So it sounds like we're hearing that advanced materials is a true enabler for industrial development writ large. That sustainability is a major concern, but that we need to think about the infrastructure for advanced materials and access, as well as materials as infrastructure for industrial development. But let me turn to Jed now, who is a representative of the private sector who may have other opinions. Jed?
Sure, thank you. Jed Patera, IBM Research, based out of San Jose in California. I have about 30 years of experience working in various aspects of materials and chemicals research, including high-performance computing, AI, and quantum computing. At IBM, the company that I work at, we develop enterprise information systems, and those are both the systems of today, classical computing systems, as well as the systems of the future, and in particular, quantum computing systems. In all of those cases, there are areas where materials innovation makes a big difference. We just announced that we now have a roadmap, we have a path to building transistors at the sub 1 nanometer node. So for those of you that are familiar with materials, that's less than 10 unit cells of silicon or most typical hard materials. So for some things, we work at the very small length scales. In other cases, we work at much larger length scales. And that's one of the things that I like to remind people when we think about materials. So to give a good concrete example, coming from the, taking the world of metals to talk about it. If you look at platinum, there's about 180 metric tons produced per year. Niobium, which is something that we care about as a highly superconducting material, is 3 orders of magnitude more, 112,000 metric tons a year. Both of those are dwarfed by the production of steels, whether those are high performance steels or regular steels, which are billions of metric tons per year. So as we think about the industrial application of materials and the supply chains, we also think about how we scale those supply chains. It's very hard to have a broad commercial impact with a new material if you can't deliver it at the scale that's required for a particular market. So that's how we might be making stuff, but we are actively involved in and looking at how we then use those tools of AI and quantum computing to develop new materials. And I do want to add an order of magnitude to something that Jerry said in the introduction, which is that it's now very routine for well-defined materials problems to be doing computational screening exercises that are on the order of millions of materials, not thousands. And in some cases, particularly in the biomolecular spaces, on the order of billions of potential materials. Dealing with that data volume, dealing with that data diversity is a challenge, but also dealing with the multi-objective optimization that has been brought up already is something that I think is critically important. So the people that are experts in materials performance are not necessarily the people who are experts in materials recycling or materials life cycle. And the more that we can provide tools both for collaboration, tools for and capabilities for collaboration, those could be automated tools, those could be organizational structures, the better we're going to be able to introduce sustainability as an early design consideration for materials.
Thanks so much, Jed, and thanks to the panelists for this first round. I think it sounds like for you, Jed, the revolution in how fast we can screen the materials is a game changer. But we also heard a real turn to supply chains, as well as the word platforms quite a bit in terms of what kinds of infrastructure or things might be needed from policy and society. But I want to drill down now a little bit into the sustainability question, which has come up quite a bit already, but to invite some deeper thoughts and reflections on the question of how to ensure sustainability, what sustainability really means in this context. We've already heard that it can relate to issues of sustainability in terms of supply chains and resilience. Are we talking about other kinds of sustainability here? Let me suggest that we change the order here and start with Marie-Pierre to reflect on issues of sustainability and what are your reflections in that area?
Thank you. That's very interesting because I used to be co-chairing the Net Zero Advisory Body some years ago. And for me, sustainability was a key. And we knew that advanced materials with some properties, or when used, for example, in clean tech sector, it would help in that sense. So I just wanted to take this opportunity to add the fact that we decided to launch an initiative to try to gather all the ecosystem, the players, the researchers, the industry around kind of a roadmap, to help the ecosystem to better focus on sustainability. And of course, we choose to be agnostic related to the material to choose, the advanced materials to choose. But the thing is, we knew that we had to help our own ecosystem advanced materials for them to be more to reduce their footprint, for example, but also to help reduce the footprint, ecological, environmental footprint of other sectors such as energy, transportation, electronics. So that roadmap was very interesting because it was a way for us to resolve major societal challenges such as, and it was mentioning previously, complete the energy transition and decarbonize the industry, also to increase productivity with the digital transition, but also to secure our country's, let's say, strategic supply chain by reducing its dependence on different foreign minerals, materials, components needed to fuel the transition. So for us, that's how we did it, how we try to introduce sustainability and practically, basically, just to give an example, Prima usually launch some call for project where companies and researchers will work together to develop or introduce new materials in a specific product, for example. So since last September, it's mandatory. Every promoters that submit a project to Prima needs to justify how it will be using different strategies related to circular economy. So that's our way to try to help and shift the sector to make sure that eventually, and we had as for the objective of our roadmap 2035, to make sure we can help support develop new advanced material, more sustainable materials. That's the way we did approach it. Of course, there's a lot of other things on the roadmap, but mainly that's how Prima tried to help and shift the ecosystem regarding sustainability.
Thanks, Marie-Pierre. That's super interesting. I think the way in which actors were coordinated around a goal. So it was a kind of goal-driven approach more than a particular material-driven push approach. I think this is consistent with how some of the science and technology and innovation policies are being formulated around the world as sort of a challenge-based approach. Let me turn to Jed to see how sustainability is being defined, but also as a concern in what you're doing.
Yeah, so I'm going to use a specific example. I am co-PI of the PFACTS program, which is a collaboration between industry, academia, startups, and the National Science Foundation here in the US to develop data resources for understanding, addressing, replacing, and capturing forever chemicals, so fluorinated materials. We got interested in that topic in part because of the sort of environmental responsibility question, right? These are materials that can persist in the environment for great lengths of time, but also because of the deep supply chain risk question. Some of these are materials, they're high performance materials, they have very specific properties, they're difficult to replace, but the primary manufacturers were exiting the market. And so as an industry, we have to come up with alternatives. However, when we come up with alternatives, we recognize that we didn't want to make the same mistake over again. And so the point of the PFACTS program, or one of the central themes, is developing the data and the know-how and convening the group of experts that can look at materials, not just from their performance properties, but also from aspects of environmental persistence or human health, or technical controls and capabilities for managing the use of those materials. The common term, but I think one that is very important, is as we do materials innovation for sustainability, we want to try to avoid regrettable substitutions. That is, we don't want to come up with a replacement material that, while it may have a smaller carbon footprint, it may also, have a bigger human health impact. So we're always dealing with a kind of multi-objective optimization there, and we try to, be as informed as possible and do the best that we can across that complex space.
Thanks a lot, Jed. Let me now turn to David.
So I think Jed and Marie-Pierre have touched on a number of points I was going to raise, and they've done it much more eloquently than I could. I'll step back a little bit and look at the high level, and perhaps there's 2 points I'll make. The first one is almost philosophical, but it's sustainable by design. So that's not how we tend to manufacture things. But if you abstract yourself for a minute and say, if I had to manufacture something and I was obliged to take that material back, I might have a different view on what my design window is. And I think that that could sit in policy. It's very hard to think about how you implement that, but that is, I think, something that has to come through in a mindset. How do I unmake this as effectively as I make it? So how do I really close the loop on use of resources? And I think that's something that is starting to get thought through, but I think it could be enacted in elements of policy in certain places. The other point, which is often overlooked, but I think is probably more if equally important to that, is we've got huge amounts of fantastically recyclable materials being used already. What we've got generally around the globe is terrible infrastructure for collecting those materials and actually recycling them. So things like aluminium and steel, plastics, they're incredibly recyclable. But unless we have the infrastructure to actually take those materials back, recycle them, we're just fiddling whilst Rome burns, essentially. So for me, one of the key things is thinking about all these input in place, and a lot of that challenge is socioeconomic. It's not about the science. It's about that broader picture and the environment in which you operate. I think governments have a big role to play in that. I think that really has to be done at a top down and say, well, how do we put this structure in place? Because a lot of this stuff crosses borders and boundaries. But how do we truly look at putting the infrastructure in that's going to enable us to get the big wins in at the moment? I think Jed already mentioned at the start some of the huge volumes that we think about in some of these materials. Well, we should be thinking about and addressing those aspects, and we need to do that urgently.
Can I follow up on?
Please, absolutely. Go ahead, Jed.
Yeah, so I want to give an example. We used computational chemistry to invent, that and experimentation to invent a recycling technology for polyethylene terephthalate. So this is the plastic that's very commonly used if you have a clear plastic water bottle or something like that. It's a great material. It's highly robust. It can withstand significant pressure. There are some markets where PET recycling works very well. For instance, in Japan, where all of the PET is clear, it doesn't have any colorants, it doesn't have any additives. There are other markets that we explored, for instance, here in the US, where there are a diverse variety of different colors of the plastic water bottles, soda bottles, etc. And that diversity actually meant that the recycling waste stream was much more challenging to deal with, and required many more kind of cleanup and purification steps than in another environment. And that's a case where it was a social policy that made circularity of a material or recycling of a material much easier or much more difficult.
So I think we're hearing about the importance of seeing the materials innovation challenge as very much engaged and entangled with infrastructure and broader institutional structures. So I think that's a core point. I think also the idea of by design puts focus on that optimization and governance can happen in the course of innovation. It's not just an add-on at the end. With this kind of using these as design properties or optimizing for certain values or goals can be a way of building in before we regulate at the end. So I want to go to one last question before turning to the audience here if they have any questions. In particular, this is going to be about the innovation system and processes for trying to get new materials from the laboratory or from sort of early stages into markets. So, what are the kinds of challenges or impediments to scaling up, to getting things out there? We've heard a lot about the social institutional frameworks, but what about investment? What about some of these other challenges in the field? So let me start with Jed. Would you like to take that one?
Yeah, sure. And I'm going to start at the early edge, which is the materials discovery phase. We've gotten very good at whether using traditional computational models or AI at hypothesizing materials that have high performance for particular applications. As many people in the field have now identified that even just making the lab scale sample of that corresponding material can often be a challenge. And that's where user resources and other kind of mid-stage facilities, like I think Marie-Pierre had mentioned earlier, can really help kind of bridge that gap. Taking things from on the computer screen to something that's actually been tested in the lab. But then there's that next stage of scale up to, essentially pilot production. And it's important to have either the partner, which is something that we have done in the past, having, a partner ecosystem of expertise that really knows how to do pilot scale proof of commercial concept for materials in a certain application space, but also an understanding of the market, right? Once you start talking about pilot scale, you're talking about making non-trivial time and capital investments in a material. And so having the right ability to judge when it's appropriate to take that leap, I think is very important.
Great. Can we move to David?
So I think Jed's touched on very eloquently on a number of points I was going to raise. That whole thing about the going from discovery through to scale up pilot is really important. Of course, the risks rise as you move further along that chain because the costs start to rise dramatically. So you need to have more focus. I think what I'd add it's just the dimension of pace and time. So historically, new materials innovations, typically, if you look back through history, 25 years really to go from discovery to commercialization of a material. It's horrendous how long it is. So what we've got to do is, on the one hand, then get more investment into this area, because all the stuff that Jed's has talked about costs money, right? So and the governments haven't got a lot more money. We need that from the private investment. But the private investor community has to understand there's going to get a return on their investment in a reasonable time frame, because materials deep tech, right? It doesn't turn that round quickly. So a big part for us, I think, is speeding that process up. And I think we can probably come back to it maybe a little bit. Maybe some people ask questions. I think digital is seen, or AI and digital tools, I'll call it material 4.0, because I like to think about a digital thread that runs through all of this, has the opportunity to speed up aspects of that. But there are still challenges. You've still got to move information and data across different elements of a supply chain, ultimately, when you're manufacturing something. It's rare that one company makes the whole thing. So I think there's challenges and opportunities there. But if we can accelerate that, we can put those processes in place, sit those alongside the scale up, and make a pilot plant that Jed's talked about to make that transition from the lab through to manufacture at scale and proof at scale and accelerate that. I think the investment will come, the confidence will come from that community, and hopefully it will become a virtuous circle, because ultimately there's huge value in materials innovation. I just don't think the investor community really understands or gets that yet because of the timeframes associated with it. So that's why I'm really keen in us trying to sort of get out of that spiral that we're in. I'll be interested, because I'm sure Marie-Pierre's got some views on that as well.
Please, Marie.
Yes, and I do second what Jed and David just said earlier, but about funding. Well, first of all, I would just like to say that from my perspective, which is one much more of an ecosystem one. I think that we need a solid ecosystem in which region where we work to, to make sure that people work together along the innovation chain, helping researchers and companies, of course, but also the funding chain. That's interesting because we just launched, I think it's 2 weeks ago, a diagnosis of the funding chain in advanced material in Quebec. I know it's a small scale. There will be an English version by the end of the summer. But what was very interesting is that we matched our data with the PitchBook data, and we saw for the last 12 years, companies were much more working with incubators, second incubators, third incubators. I mean, when you're at the third one, maybe something's wrong, There was VC also, and the VC, they didn't know about what were advanced materials. So we have a lot to do to make sure they understand what it is. It's deep tech, of course. And luckily, what we've learned also is that the fact that VCs are starting again to be interested in deep tech, well, in Canada as well. So there's a lot of education, if I may say so, to make sure they understand what it is, because it needs longer term investment. I mean, it's not the VC model in Silicon Valley, for example, for apps, which it takes not much time. Advanced materials, deep tech sector, it's more longer term. And of course, there's a longer maturation period before it will generate some substantial returns or revenue. So yeah, that's what I would add to what Jed and David said.
So before going to the audience, I do want to come back to one of the goals of this panel, which is to really identify some exciting developments. And I wondered if you were, in terms of new materials and exciting developments and trends, and I wondered if you were trying to explain to a policymaker, here's an amazing opportunity, here's an example of one or two technologies that will revolutionize and address some problem. What would you say? Let me turn it to David first.
So the first thing is I wouldn't lead with the material, because that doesn't capture their attention. I'd lead with the application. Right, so that captures politicians' attention. I mean, I'll leave others to talk about other areas, because I'm sure there's lots of interesting stuff, different topics. For me, health is a really interesting one. So the real opportunities, I think, going forward are things, bioelectronics and those applications. So you don't just need a bio-compatible material, but you've got now material or a system that's interacting and with communication channels in the human body. Now, there are lots of materials that are coming out, the conductive and biocompatible graphenes and various 2D type materials that have that conductivity associated with them. Some really interesting, really fascinating stuff that's coming out. Some of it's based more in sports medicine, but it absolutely translates across into sort of health, real health issues. I think that's incredibly exciting. It's incredibly multidisciplinary. And someone pointed out to me the other day, which was pretty obvious. So we sit in an environment where there's the most advanced manufacturing of materials going all around us, and it's all in nature. Sometimes we forget about that. And it's doing it incredibly efficiently, and it's got these huge, really interesting pathways and interaction with the hosts, etc. they're associated with. So for me, that's the exciting area. I could talk to you about all the classes of materials that sit within there, because it covers everything. But that application for me, I think, it could set huge things alight in the next few years. Of course, it does require other materials innovations to come through, but it's that application that I'm really excited about.
Great. Let me turn to Marie-Pierre.
I would second David. I would also add maybe the use of materials for the electronic sector. And of course, I always have in mind decarbonize the sector through sensors, semiconductor. I think it would be very interesting also to the industrial process automation, which we have to do more and more. So that's what I would add for this moment.
Great. And how about Jed?
Yeah, so I would second Marie-Pierre's comment about industrial automation. Particularly for complex industrial processes like semiconductor manufacturing, just understanding what the materials footprint is of that chip that took 2,000 steps to make is itself a challenging problem and a worthwhile endeavor. But if I was talking to policymakers about materials innovation, going back to the masses of materials of metals that I was talking about at the beginning, the less material that you can use to create some sort of new property, new value, the faster it's going to be able to be adopted. So not just in areas of biology and biomaterials, but also in areas like catalysis, where a small amount of material can radically change the energy footprint of an industrial process, are areas that I think are important for innovation.
Great, Jed. I'm going to try to turn to the audience using the Q&A function. And I'm not seeing, here we go. I want you in the audience now to feel free to ask questions for the audience through the Q&A function. So if you see that on the three dots at the bottom of the screen, one can add questions. Anything coming through here? So not seeing a question yet. Let me put another question to you. It sounds like in the discussion of some of these cutting edge techs, we see kind of the important interpenetration of different technologies. And we see how the convergence of technologies is particularly important. How might you reflect on that? But I do reflect on that, but hold that. I do see a question. I want to turn the audience here. What about regulation? How do you see a sandbox solution depending on failure and risk related? Does anyone want to weigh in on regulatory sandboxes as a solution to some of the regulatory issues we might have currently?
It's a tricky one, right? So I think, I mean, it depends where the materials are being applied. I think when we've been developing the material strategy work in the UK, regulations come up a lot, right? It's come up a lot as barrier. People talk about the nuclear industry or the biomedical industry and how those are barriers to, because it takes time. It just adds, we talked about how long it takes to develop a material, that adds yet more, if you like, treacle into that process. And you've got to have that domain knowledge in that regard. But so I do think we need to streamline that. And I think that is really important. And we need to make it as simple as possible. It's not, great materials don't need the people that make those materials to understand all the regulations. We need to help that and oil those wheels. There are some other interesting ones. So it's not regulation, but it is a barrier to innovation. So when we talk to the built environments, this is domestic buildings, things like that, where you'd expect there'd be lots of materials innovation to come through. The biggest barrier in the UK was insurance. So you could not get insurance if you used a new material in a building. It would, ironically, the insurance companies are risk averse and they didn't want that. But also you couldn't get refinance because people wanted buildings built out of bricks and mortar. They didn't want it built out something new because that added a risk profile for when they were looking for reinvestment. So I think regulation is important, but there's other things that sit around it that hold back innovation. And it's been a real eye opener for me over the last 2 years that I always thought it was about the technology, and often it's not about the technology. There's lots of great ideas out there. It's understanding markets, it's understanding the barriers that are holding some of those innovations and the speed at which those innovations translating through. I'm not sure if I've answered that question, David, but that was a bit of a reflection on some of the barriers which aren't the obvious ones, I guess.
Would the others like to weigh in, or shall we go to another question?
Just one of the ways that I have been thinking about this a little bit, when we talk about material safety or operational safety, we make a distinction between hazard and risk, right? So hazard is something intrinsically dangerous. Risk, how much is somebody going to be exposed to that material? How well can we control the exposure to that material? When we talk about putting things in something long-lived, like the built environment, right? There is not necessarily a hazard, but there may be a sustainability question. How much carbon has been embodied in this material to create it versus its lifetime? So sustainability times lifetime is kind of fits with that metaphor of hazard and risk. But I'm happy to hear what others think about that topic.
Marie-Pierre, do you want to weigh in?
No, nothing more to add.
Okay.
I would just add, actually, Jed's just triggered something in my mind. One of the things on the regulation side is we talk about life cycle assessment and life cycle analysis, about measures and ways we measure things like carbon and carbon capture. That is, yeah, that's open to abuse. Let's put it like that, because it's all built on the data from where it's produced. So there's a lot of, I mean, the overused word, but greenwashing in some of these areas. So understanding that and regulation actually cutting through and giving genuine understanding to that, I think is really important actually, because that will drive some of the stuff that we're looking to do. And if we've got it wrong, we're working from the wrong basis. So I think that Jed's point is really important there.
Yeah, and I think this also gets back to this issue of being anticipatory about governance and thinking about also in addition to safety by design or sustainability by design, building in testing experimentalism with the regulatory system at the same time. And we talk a lot here at the OECD about anticipatory governance, and I think both the by design and the sandbox are interesting ways to do that. I want to go to another question. This one is from Luis Melo from Portugal. I know that because he's the chair of the Working Party on Bio, Nano, and Converging Technologies here at the OECD. He's also a professor of advanced materials, or of nanomaterials in particular. And he has a question about international collaboration. He says, in fact, there is a need for governance, including resource availability. What do you see as the role of international collaboration? I think it's a very apt question for the OECD. Would anyone like to jump in on that?
Yeah, I'd like to jump in.
Please.
I think it's a very good and interesting question. As someone was saying, I'm in a conference actually in Portugal, and they were insisting on the fact that innovation is not done alone. So you need to work with others that do have expertise so international collaboration for me would be a must. And as we did since probably 6 or 7 years, we've been able to, as Prima, meaning to be part of different European consortium like MRANET, which is based on advanced materials. There's another one, RAMP, which was launched 2 weeks ago and is led by the Vinnova, a Swedish organization on raw material partnership. So it's a way for us to make sure that companies and researchers based in Quebec, for instance, can work and benefit from the expertise of people abroad in different universities, different companies abroad. So I think that international collaboration is very much needed and important, and we should support that. And that's what the Quebec government chose to do. And last point, they did want to work on that, and we are, as Prima and other similar organization, we're trying to be more to try to develop new partnerships in the program of Horizon Europe, because you know that Canada is an associated country. So for us, international collaboration is very much important, and it helps also to reduce the risk from a scientific perspective, and can accelerate different development.
Thanks so much. Jed or David? Jed?
Go on, Jed.
Go ahead, David. No, go ahead.
I was just going to, yeah, I'm very supportive of what Maria said. I think if we don't collaborate, I mean, science is all about collaboration. It's not about boundaries on country borders. If we're not collaborating, we're lost, really, in this philosophy. I do worry the current geopolitical climate has very much almost tried to create lots of islands. And you know, and really, you know, I think science collaboration can break some of those down. And I do think the science collaboration goes along with economic collaboration actually as well, and supply chains and businesses and networks. So I think it's, you know, without overplaying it, well, I'm going to overplay it. It's absolutely essential, really. And of course, there are countries that are perhaps slightly more friendly, and you may want to work with others. So there may be some, but overall, international collaboration, I think, is essential. I mean, history tells you it's essential to huge amounts of innovation that have taken place, and the scale at which we're doing some things. Just to circle back to, I think, one of the points which Marie-Pierre said, and I know this because I sat on some very expensive equipment. I can't afford all of that. The UK can't afford all of that. Most countries can't afford it. So you've got to share those capabilities around in terms of those scale ups and access as well.
Let me
Yeah,
turn
I would say,
go ahead.
yeah,
How do we do it? Maybe Jed, you have an idea about, you know, if it's good, great, but like, how do you actually do it?
well, I don't have an answer, but so, you know, innovation is distributed, right? There are smart people everywhere. The actual manufacturing of materials tends to go through a concentration phase, right? You're either got a material that's geographically concentrated, or a feedstock that's geographically concentrated, or you've made a capital investment to produce that particular material in a certain location. But then, you know, for things that are commercially successful, the consumption and use of that material is often very geographically distributed. So when we think about the full life cycle of the material, we have to collaborate both on the innovation side of things, as well as on understanding what happens with those materials when we're done using them or done working with them. And I think those are both areas for collaboration that we need to think about.
Thanks, Jed, and thanks to the panelists for a wonderful session to get us moving here today. You talked a little bit about the geopolitical environment, David, and the danger that we have islands in technology development. I think we also are in danger of having islands of discussion and engagement around policy discussion. That's where the OECD, I think, and the GF Tech can help out. That's what we're doing today, is pulling for a broad audience across the world, dialogue on the technology, but also, as we've seen, the social, political, regulatory architectures that are implicated. So I'd like to bring this session to a close. We can, after thanking the speakers, of course, you can't hear the applause, but we can imagine it. We will take a short break of 5 minutes only to just refresh and stand up and shake and move around. And then we'll come back for the second panel on advanced materials in strategic industries. So please don't leave the meeting. Just, you can turn off your video and audio and enjoy the next 5-minute break. Thank you. Okay, I'd like to welcome everyone back to the meeting and to engage now the next session, which is on advanced materials in strategic industries. We've explored a number of advanced materials and contexts and trends that are emerging. And we start to explain or get into the importance of a goal-driven approach to materials and materials innovation. But we'll be drilling down now into those questions of how materials are playing in and for strategic industries. So this session will be chaired and moderated by Douglas Robinson, who is a policy advisor in the Directorate for Science, Technology, and Innovation. So I'd like to hand over to Doug now. Doug?
Thank you, David. I hope you can hear me and see me. Can somebody give me a thumbs up?
Yes, can hear
Yes.
you.
Perfect, because I don't see myself, so that's great. So thank you, everybody. Welcome. So as David said, I'm Doug Robinson, working with David in the Directorate of Science, Technology, Innovation on strategic intelligence. That's really looking at emerging technologies and the future. Really glad to be here. So we have, as David said, we've understood that materials are the foundations of applications, many applications, most applications. And for all of the great challenges that we have to face in the future, materials will play a role in terms of solving societal challenges, in terms of driving growth and competitiveness, in keeping our families, our countries, our industries safe and secure. And so with that, we've developed this panel on advanced materials in strategic industries. And we have a great set of panelists. So we have Philippe Babin from Eponix Enterprises. We have Theo Lombardo from the International Energy Agency. We have Mangala Srinivas from Wageningen University. And what I'm going to do is I'm going to invite each one to give a 2-minute to kind of introduce yourselves and give your first thoughts of what you find interesting in this area. Then I'll pose a question to each of you individually. And then I will open up for questions from the audience. I, of course, have questions I could pose, but I would encourage those online to start thinking while people are giving their introductions and pose some questions. I will gather the ones I think are the most pertinent and bring them to the table. Of course, you can always respond by writing in the Q&A, panelists. So please, Philippe Babin, would you like to introduce yourself? And your 2 minutes starts now.
Yes, of course. Hi, I'm an engineer with an MBA. I spent the last 25 years as a general manager and CEOs of multiple companies. I'm an entrepreneur at heart. Today, I'm the general manager of Eponix. We're based in Canada. We specialize in PIC, photonic integrated circuit. And we were acquired last year by Pascal SIS. Pascal is the leader in neutral atom quantum computing. So at Eponix, I spent the last 12 years developing products based on semiconductor and photonics processes, starting initially with university, in labs, research centers, and finally foundries. I'm not a material scientist, so sometimes I always have the imposter syndrome when I'm talking about advanced material, but I thought material all that time with the processes and processing in the foundries. So my key areas of interest for advanced material are obviously semiconductor, photonics, and quantum. 3 areas intertwining heavily in needs for advanced material with a lot of work. We've heard previously IBM talking about the sub 1 nanometer the process and roadmap. I lost $10. I bet $10 once that we've never reached under 1 nanometer. So when you think about having 9 atoms side by side to create the critical dimension of traces, it's kind of amazing. AI is today represents a massive investment worldwide. It is putting pressure on the data center point of view, massive pressure on energy, on the overall semiconductor supply chain. If you're to buy an iPhone or a mobile device over the next weeks, the price of the memories went so high, and we all remember what happened during post-COVID in the car industry and semiconductor. So this is having an impact on our day-to-day life. And the semiconductor is in that race to get more energy efficient chip, smaller chip, but also chips and system capable to provide faster and denser data communication, bringing the photon straight to the chip, which is quite a revolution. On the quantum side, today it's a $13 billion annual investment. More than 300 companies today exploring new scales of quantum computing. And so this is quite having a significant impact also on our society.
Yeah, this is really important, and you know, we did chat earlier this week, all of the panelists, and this point about materials importance for AI. We talk about AI being used to design better materials, but of course we need better materials for AI, for the energy, for the semiconductors, for improving those processes. Thank you, Philippe. Theo, would you like to introduce yourself, where you're from, and also a little bit your thoughts? Keep it to 2-3 minutes, Theo, and so we can start opening up the floor. Okay,
thank you, Dag. And very welcome to everybody also from my side. So I'm Theo Lombardo from the International Energy Agency. I guess that most of you know us, but in case you don't, we are, as the name goes, the largest international energy organization globally, and we look at the energy sector as a whole. So we look at fuels, so fossil fuels, we look at electricity, we look at renewables, we look at technologies, so electric vehicles, batteries, and so on and so forth. So we look also really at the whole energy systems and the sectors that this affects. Also from a technology and innovation perspective, that's where the role of materials and advanced materials is the greatest and the most important. Me personally, I work on everything related to batteries. I will discuss a bit about that. That is a technology that shows the importance of advanced material particularly well, because that's a technology that evolved dramatically, rapidly over the last couple of decades, and advanced materials really underpin a lot of that changes over the past years.
Thank you, Theo. Mangala Srinivasan, could you introduce yourself? I'll be just a spoiler alert. I'll be asking you the first question, Mangala. So please, you have 2 or 3 minutes to introduce yourself and what you think is exciting about materials in your space, and then I'll come back with a question. Please go ahead.
Well, thank you. It's a pleasure to be here. So I come at this topic, I think, from the interface of biomedicine, imaging, nanotech, and also policy. I am professor of cell biology and immunology at Wageningen University in the Netherlands, and my research focuses on developing advanced imaging agents, which is basically nanotech, for MRI, so imaging in humans. But aside from that, I also work in the group of chief scientific advisors. So we work on policy related to this matter, which I'll get to shortly. But in my own career, I have also worked in industry. So I worked in GE Healthcare for a bit, and then for my own spin-off. So I know how it works from both sides and how innovation is really important. But going back to the policy issues, so the group of chief scientific advisors, there are 7 of us, and I'm currently deputy chair. We are part of the scientific advice mechanism of the European Commission, and we provide evidence-based policy recommendations directly to the commissioners or to the parliament. And I guess the reason I'm here is because in April, we wrote our policy recommendations on advanced materials. And aside from that, for my own research, we also have an upcoming paper in Science on empowering researchers as innovators. And I think my take on advanced materials is that, you know, they are just absolutely essential for our modern lives now. There's no question of that. And we need to strike a good balance between sustainability and innovation.
Thank you very much, and very much interested in the different types of materials that you work with in this area, but also your role as as part of a scientific advisory group. My first question, we often think about biotechnology and advanced materials separately. Yet increasingly, they form part of the same innovation ecosystem. So we have the technologies coming together, but we also have the innovation ecosystem coming together. It's part of your entrepreneurial point you were making, where science does move into industry. What capabilities do you think countries should be developing today if they want to remain competitive and nurture that entrepreneurial spirit and really get the materials and other scientific outcomes into industry, into those strategic sectors? But particularly interested in health because that's where you're predominantly located. Please, do you have answers for
Yes.
me?
I think, first of all, we should not separate biotech from advanced materials because almost all biotech now is based or heavily reliant on advanced materials. So this is kind of a false distinction.
Yes.
And when it comes to the capabilities, I'm going to list 5 and I will be brief. I think first is the skills that people have, so the convergent talent, because we need people who can really work across fields. We need to work across material science, but also biology, engineering, in my case, imaging, and regulatory and manufacturing as well. So we need people who are trained to do this. And this is something we also highlighted in our opinion, actually, but that's a very important topic. And the second, I think one of the earlier speakers also mentioned in the previous session, is that there needs to be shared infrastructure. Because one of the other speakers said it's really expensive to do some of this. And I think especially in biotech, and if you want to do something for clinical use, so the manufacturing at GMP and at scale is often just too expensive for a research group or a small company to handle on its own. So there needs to be shared infrastructure. And the same applies to data. Right? We need good ways to share data that is fair, without sharing trade secrets and so on. So there has to be a good balance here. And the fourth is on the regulatory side, and I've seen this in my own research. There is not a lot of clarity on how to regulate new materials. So, for example, we're having a clinical trial soon with nanomaterial-based imaging agents. And then there's always a question, do you regulate it as a drug or as a nanotech or as a perfluorocarbon? And this just makes the whole process complicated. And I think the last point I'd like to make is that there needs to be a lot of support for researchers as innovators. And I say this as an academic because, we're often assessed on papers and grant writing, and starting a company or developing a new material or filing a patent doesn't lead to any of those. So there needs to be space for academics to also dabble in innovation and also to fail at it, because otherwise you're not going to succeed.
Exactly. And I was having a discussion this morning with a researcher who's thinking about this, and a hesitance because of the culture of entrepreneurship also needs to be nurtured as well in this area. I think one of the things that struck me about what you just said was the shared infrastructures. This is key. As we heard earlier a little bit about the long time frames for some of these really key novel materials. And, small companies really need support. Not only the infrastructure in terms of physical infrastructure, but let's say the innovation infrastructure to take it along that journey. I think this is something we may come back to later. I'm going to move to Theo now. Theo, so you work in energy. The energy transition is often presented as an energy challenge, but is it actually becoming a materials challenge? We chatted a little bit about this in the prep. What do you think about that?
Yeah, thank you. I think that's true. And the energy, if you look at particularly at the energy transition, it has been since a while. Now it is more and more a material challenge. And if I can broaden a bit the question, if you look at the energy sector overall, it is increasingly material based.
Mm-hmm.
If you take a bit of an historical perspective, the energy sector in a sense has been in the past defined as fuels that was providing energy and materials technologies that was underpinned by materials that were used to use that energy in the most efficient way possible. Think at oil and the internal combustion engine car. Okay, that was one the fuel and the other the technology and the material. In the energy sector now, the role of materials also for the creation of the energy in the first place and management of that energy is increasingly important. Think at solar, think at wind, think at batteries. And these are technologies that are having and already have a growing role in the energy sector, fossil fuels and fuels in general still play a dominant role, but these technologies are growing rapidly and are already sizable in the global markets. And some of the technology also change in the process. I mean, if we and I look in particular at batteries. So if you look at the case of battery technologies, that now is a pillar of many important energy sector. It's revolutionizing the automotive sector with electric cars, and that's the biggest oil demand sector globally. Is powering more and more and supporting power grids with the electrification and the integration of greater amount of intermittent renewables. So batteries are having an enormous impact on the energy system overall. And just 10 years ago, it was basically a technology that was fairly limited to power electronics, our smartphones, computers, I mean, things that matter, that have real world impacts. But in 10 years, really the focus of this technology and the evolution of this technology in terms of innovation and materials brought it to a point in which it has an enormous impact on the whole energy system.
But I think what's interesting here is the cascade effect of advances in materials in batteries in systems, and how that's evolving over time. This is interesting, and I think one just further remark is, I guess the advances in materials in batteries, for example, there's a co-evolution of the battery with the devices, with the other technologies, which poses some challenges, I suppose, because you have to have multiple technologies arriving at the same time to be able to really take things forward. Just a follow-up, you mentioned the last 10 years you've seen this rapid development. Do you recognize that challenge around these material research and innovation and its combination with other technologies, and how you time that and get that together?
Yeah, definitely. That's completely correct. I mean, in general, that's a field that is evolving very rapidly. And then in a sense, different pathway for innovation need to be tested at the same time.
Yes.
And with different time scale in mind, right? There are certain technologies, for example, certain battery chemistry or certain battery innovation that are being done with a time frame of a few years in mind. That are others that are being tested with a few decades in mind.
Mm-hmm.
So basically, it's a classical sort of concentration, if you want, not putting all eggs in a basket. And then there is several technologies with some that are more important than others that are tested and brought forward and improve also in a stepwise way continuously over time. And maybe something also to highlight is that here material and technology innovation is paramount. The performance of batteries and the cost of batteries increase and decrease respectively impressively in the past years. In the past 10 years, the cost of lithium batteries decreased by 75%, while deployment really exploded. But at the same time, is also an industrial challenge. Mm-hmm. So the material innovation is what underpins the evolution of the technology, but these technologies, to have a real world impact, need also to be brought to the market at sufficient volume to affect the market itself. And then the capacity not only to reach excellence in technology and innovation, but also to bring that at scale and decrease production costs and accelerate and increase the scale of production, those are very critical as well.
I think so. So some remarks, and I know I think David Knowles is still on board. There's a whole idea of coordination and road mapping, which is a key thing in this area, of course, and how you coordinate different actors. And you mentioned multiple avenues. You've got to test out different options at the same time. You're also working at multiple time frames. Some things move slower than others. There's coordination, so road mapping, but there's also a need to prepare and engage with industries which perhaps be conservative, or they just require large reconfiguration to accept these new materials. So this is something perhaps we'll come back to later. I'd like to go to Philippe now. Philippe, again, you warned me in our pre-discussion that if we start talking about quantum, you could spend hours on this or days. But I have a question on quantum, and my colleague Andres is online, is very interested, of course, on quantum. He works in this area. When people discuss quantum computing, they often focus on algorithms and qubits. But how much of the real race is about materials?
A lot of the real race is happening, and it's next to the semiconductor foundries and different types of foundries. So basically, when you look at quantum, We got quantum computing on one side, and also the other areas. But basically, when you look at it, you got to look at it from there are five and more, but let's say five different technologies in quantum computing. The first one is superconducting. This is something we've heard previously about with IBM, where basically we're talking about Ide-Josephson junction or superconducting qubit chips, basically built in special foundries and having to push on processes and material for to be able to operate the material and get the effect at either higher temperature and obviously keep the noise low. So there's a lot of work, but this work is tightly coupled with the foundries. Second one is photonics. If you look at the photonics, quantum computing, Xanadu in Canada, PsiQuantum, many of them, they are fighting against optical losses and noise again. And to be able to do some of the processes using silicon nitride as a material, as an example, is a key point. So all the work on the silicon nitride processes and material is a key point in the photonic space for these. Again, much of it is happening in the foundries, but also everything related to the 3.5 material, everything related to the light source, the SPADs, and then the laser sources. Basically, there's a lot of work happening, and there's not that many 3.5 foundries around the world. There's a few of them. Many of them are controlled by a large corporation. Their access can become a challenge and can become critical in the futures. Ourselves, cold, neutral atoms. So basically, this is where we stand with Pascal. This is where we work. The key challenge for us in material is being able to generate the laser needed because these quantum computer requires a big amount of laser, large quantities of laser. So we're building these laser with photonic integrated circuit PICs, working again with the same material we spoke about, silicon nitride, the need with 3.5 gain chip elements, specialized, low noise, and adapted for the quantum space. Also, thin film lithium niobate, a few of these foundries that will provide some of the component. And finally, even in ion traps, the fourth category of quantum computer also is happening and around these foundries. And I'm saying foundries, these are not necessarily the one you're hearing about working on these memory for your mobile phone or the CPU, GPUs, but they're sometimes smaller or less, should I say, less visible foundries, but there's a lot of work happening there. There are two other areas in the quantum space. We're talking about sensors and also quantum communication in the sensor space. This is typically the same race for photonics, again, the foundries, new material, NV diamond is an area where boiling with quantum computing, quantum sensing, and quantum communication is another one very interesting from the point of advanced material because quantum communication, again, there's a telecom portion of that, but also the upcoming field of quantum memories, quantum repeaters, very exotic material, rare earth material like erbium, ytterbium, ultra-thin 2D material, and so forth. This is a vast sector. So all in all, the advanced material is definitively playing a key role in the race to quantum computing and computing in general.
Well, this is fantastic. You lay it out, and you mentioned 4 of the 5 quantum computing ideas, and just for the audience, there is no definitive, let's say, dominant design of a quantum computer yet. There's explorations, as Theo said, in the energy space of multiple ways of doing these. And Philippe just walked through some of them, and all of them depend on different types of materials. And also, as you said, the quantum repeaters requiring kind of exotic materials, rare earths, which also lead to some challenges in terms of building those up, the supply chains, etc. So I'm going to I'm going to ask the audience, please do put questions in the Q&A. Please do so. I will draw upon those. I will encourage you to do that. For the panel, I have a few questions. You know a little bit about them because I give you a forewarning of some of them. I'm going to ask about advanced materials as a strategic capability. And if I don't hear from the audience on another question, I'll come to critical firms in this space. So the advanced materials is a strategic capability. So it's very clear now from our discussions in health, in energy, in computing and sensing, but in computing in the main around what you've been talking about, Philippe. Advanced materials are a strategic technology. They move advanced materials in the computation, in the different types of energy systems, in the health. So they're an enabling strategic capability for countries to build a competitiveness, to grow new markets, to really solve key societal challenges. So I think one of my questions are, how should we change the way governments think about investments in this area? What could governments do to improve and steer and grow advanced materials for these strategic sectors that we've discussed?
I don't know if someone wants to start. I can.
Please go ahead, Theo. And I can see you, so you can raise your physical hands,
Yeah,
Philippe and Mangala, if you want to jump in. Please go ahead, Theo.
Yeah, maybe a general point also to make a link between the different presenters. So all the topics we are touching are very interesting, but the point is that also they have things in common. I mean, when we speak about strategies about advanced materials from a policymaker perspective, the challenge is that advanced materials can touch a lot of different sectors and can mean a lot of different things. Advanced materials is a very broad class that is, I mean, it can be a lot of different things. So something to have in mind is that strategies should be tuned as a function of what's the target and what's the sector.
Mm-hmm.
Mangala will tell us more, but probably when you look at advanced materials for bio application, the priorities should be a bit different than when you look at advanced materials for batteries, because you have different type of competition in place. On the one side, the main focus is improving the health of people. On the other is unlocking lower cost technologies or better performing technologies, competing in global markets. So the target can be a bit different. And then also the pace at which things evolve can be a bit different. Maybe a striking statistic I can bring for the battery space to give a sense of how rapidly this sector evolve is that if you look at patenting, that's an incomplete metric for seeing how fast an innovation sector evolve. Energy patenting is about 10% of the total, just to put an order of magnitude. Out of this 10%, over 40% in 2023, that is the latest data you can get for a patented field in 2023, was batteries. That is a share that was never commanded by any technology before. So they give a sense of how fast this sector evolved. And another element, I'm touching to something like that you discuss about these industries that might move slower or faster than the academic sector, for example. Not only the manufacturing leadership, but the innovation leadership is so important in such a market that it's an enormous market now. It's 150 billion in 2025 just for batteries, and it underpins much bigger markets like automotive, etc. That take the biggest battery company in the world, CATL. They have over 20,000 R&D personnel. So they have only one company have over 20,000 people doing research daily for this technology. Combine this with the over 40% of energy patent that are batteries, and give a sense of how fast and how important innovation is for this sector, for example.
Thank you. I'm going to read because there's a related question in the chat about pace, about challenges from getting materials out there, so to say. And Mangala, I am thinking a little bit about some of your points, your 5 points about the regulation aspect. There is a panel that will look at governance and policy issues after this one. That I'm not degrading it, but there's certainly that is a key issue, because I was thinking about coatings, of course, Theo. When you look at materials as coatings, you can see them going in multiple industries, and there are different regulatory pathways in those industries for the same material, so to say. But anyway, the question that Tyler, hello Tyler, we know each other from other committees. So Tyler has a question. I'll read it out. Where do you see the greatest gaps between advanced materials innovation and real-world adoption in strategic sectors? And which policy, investment, infrastructure, standard actions would have the greatest impact? So a very big, bold question. Would anybody like to answer? Please go ahead, Philippe.
I like that question. There's definitively a long and big gap. We're in deep tech. Deep tech means the core patients. In my opinion, one of the key points is the access to infrastructure and access to shared infrastructure. I believe that definitively this access is important, has to be secure in some countries, but across or multiple countries. This is definitively going to be of a challenge of having these access. We want to avoid going back to what happened in the history with the semiconductor. I think there's a lot of learning there that we must do. So that shared infrastructure obviously is one point. The second one is the access to the materials. So I believe it's quite important to have strategies in the countries for access to critical minerals and having a clear policy and access. And finally, patience in the program, because I can tell you the journey is long. The road from lab to fab and market is a long one. It does require patience and to have program adapted to cope with that deep tech. Okay, so these would be my points.
This is really interesting. Of course, this resonates with Mangala on the shared infrastructures and data. Mangala, you raise your hands. Please go ahead.
Yes, I just wanted to echo that shared infrastructure is especially important in healthcare because, as I said, GMP manufacturing and upscaling is just really expensive. But in addition to what you said, Philippe, I would like to add that I think policymakers, it's always a hard balance between, regulating for safety and sustainability and so on versus tamping down on innovation. So the way we try to get around this is by saying that you need to think about sustainability and safety by design principles from the beginning, but the regulations only start coming in at higher kind of technology readiness levels, as we call it in Europe, so as the technology develops, rather than in the early stages in the lab. And I think we also need to understand that, policymakers have gotten it wrong in the past and not to focus on policy too much, but like with the CFCs and the ozone holes or microplastics or even PFAS, right? And it's always a struggle to not bring in regulation too early when the evidence isn't strong enough, but then if you wait too long, it's too late. And how do you do this without breaking public trust, right? Because I think that's in the end really important.
I think it's important, but also the anticipation of the loss of public trust by firms who might be taking a risk of bringing on new materials, right? Because it is a risk to change the way you're producing certain products and bring in new materials. And so it's really key. And this is interesting. I mean, in the previous panel, we had a discussion of regulatory sandboxes where you could learn as you go, so to say. And I know in the next panel, we'll have a discussion a little bit on safe and sustainable by design. But I think the key point is safe and sustainable by design. Regulation comes in at later TRLs and some learning as you go. I think there's some big lessons to be learned there and really about exchanging, I wouldn't say best practices, let's call them practices for now, at least exchanging on this between countries and different sectors perhaps. Yes. Does anybody want, Theo, do you want to respond or are you okay? By the way, dear panelists, you can also ask a question to each other. So please do so if you wish. Theo.
Yeah, I mean, I very much agree with what has been said. So echoing similar thoughts on a more energy perspective, I think that something that is important to have in mind is this double things that is true. That for certain, in the energy sector is true, but also in many others, I'm sure that in quantum computing and semiconductor is true as well. From the one side, speed of the race is important. So being able to innovate and bring things to the market at scale rapidly is important. But at the same time, this capability of bringing this technology and innovate rapidly, bringing them into the market quickly, is underpinned by things that are often overlooked or not visible, but they are the backbone of this capability. I mean, a technology that appear and revolutionize, or that's a breakthrough, these kind of things that are very journalistic and very nice, and that have a real world impact. They are based on years or decades of research and manufacturing experience that combine themselves to be able to bring these technology innovation in the market timely and in a rapid way. So I think it's important to have these two elements in mind, having the capacity to bring this innovation and bring them into the market, and the fact that this capability is anchored on experience that is developed over years or decades. It's not something that you can do overnight.
Yeah, I think this is important. I mean, so there's a number of things. The access to shared infrastructures, partially or large part because of cost, but also the opportunities for exchange around those infrastructures. I'm looking at the biotechnology space, which I've also looked at in the past, particularly industrial biotech, shared and connected infrastructures are one thing, but also in terms of building shared data practices. I mean, Mangali, you mentioned about data exchange and data standards earlier in your intervention. I think this is also key as well. I think maybe it was Philippe who mentioned patience in investment. And so we're really coming up with a lot of policy areas of policy advice here. Theo, you raise your hand, and then I'll read. Oh, great, another friend online, Adriana Sips and Luis have some questions. But please, Theo,
we can leave space to the question. I was asking a question myself.
Okay,
just from Mangali in particular, but happy to leave the floor first to the audience, and then we see I can ask it in case there are no questions at some point.
Please go ahead. If we keep the response short, and then we can bring in the questions. Please pose your questions here.
I try. Mangali, I don't know if it will be a short answer because I don't know the answer. But yeah, I mean, something that attracted my attention is the fact that you were saying that in the biosector, advanced material can be classified differently. If it is a material, it is something that is a medicine or a treatment, and then the regulation change and this impact the way in which you test it, innovate it, and so on and so forth. In your view, how can you handle this, I think, inherent kind of dichotomy? How do you think that the regulator should be this problem and try to fix it, if there is a way in your mind?
I don't know how to fix it, but I can tell you the problem from my own experience. Because as I said, with my company, we try to bring a nanoparticle-based imaging agent to the clinic, and regulators freak out when you say nanotech in the clinic because this is relatively new and no one really knows what to do with it. And so they treat it like at the highest safety level, which just makes it too expensive for development. So I think we need, I'm not saying regulators should take risk, but I think there needs to be more training so people are kind of more up to date about what is really going on in the world and what the evidence, where the evidence stands. But I raised my hand because I also had a question for all of you, or maybe someone in the audience if they're interested. Which is that, we're talking about advanced materials and how it's really important to our way of life and we can't do without it, right? But making them safe and sustainable, it comes at a cost. And I think this is a short-term investment in a sense that it will save money in the long run if you think of climate change and critical raw materials and so on. But, to take an example from the battery field, it would be a lot cheaper, I'm guessing, to make a throwaway battery than one in which you can recycle the critical raw materials at the end of life. So who do you think should bear the cost of this and who should be responsible? In my opinion, and this is also what we wrote on advanced materials from the GCSA, is that we think it just needs to be mandated because it is hard and no one, I guess, is going to volunteer to do it. But at the same time, we feel that we have an ethical responsibility to consider environmental costs also for the future. How do you see this?
I think that's a very good one.
You should answer, Theo. I was just thinking one point is, of course, this who pays the cost and who gets the benefit. That sometimes is at a distance and diffuse in certain ways, and so upfront costs, the people put the costs up may not get the benefits immediately, and that's one of the issues. Please go ahead, Theo.
Yeah, I think it's a very good point. I think we need also, as a sense technical expert, to have kind of a bit of a dynamic view. I mean, what I mean is, let's take the example of batteries. That's a very important one because, I mean, if you don't recycle them, if you dispose them in landfill, that's not only an environmental, but also a safety and health risk that should be avoided. and that I think will be avoided exactly for these reasons, because there are valuable materials in it, because the society say cost of not doing it will be high, so there will be a societal pressure to do it anyway, either through mandates or because there is economics behind it. My expectation is that it's a combination of these two. It depends a bit on what will be the condition in 10 years. But my point is that these things, you have to this thinking of making a technology as recyclable as possible and as as optimal in terms of full life cycle as optimal are important, need to be integrated to the extent possible, meaning that in the real world there is a compromise to be done at some point. And then also the overall picture is important. If you make electric cars with batteries that very likely will be recycled anyway, but they are not the perfect design to make the recycling the cheapest option, from an environmental perspective, it's still much better than spending 5 years more to build that car and drive an internal combustion engine in between. So there is in the real world, I think there is some trade-off that need to be found. And the role of policy, in a sense, is also to try to indicate which are the most acceptable from a society perspective trade-off. So to have this full life cycle consideration in mind from the start is important, and incorporate also these trade-offs in your thinking, industrial strategy, and governing and policies, I think, need to be done as well.
I'm going to move on to another question in a moment, but I think this is a key issue, something that should be taken up to the next panel. So, Adriana, we worked a while back on nanomaterials and regulation and risk. Your question about safety, sustainability, and regulations, this is really a great question for the next panel. So I would ask the panelists, if you'd like to write an answer to Adriana, please do so, and that will be taken up into the next panel. What I'd like to do is, one thing that's kind of comes from what you said, Mangala, and from Theo, is exactly the whole fact that material research and development industry working on, let's say, products, systems. They could be electric vehicles. It could be parts of the grid in the energy sector, about batteries, the battery developers, those who are working in energy, let's say therapeutics, Mangala, or medical devices, materials for medical devices for application in the sector. Plus, policy makers have to think together about how to distribute the costs and rewards in a timely manner that incentivizes this process, and that's going to be a difficult one. But I think that's an open challenge for policymakers and other stakeholders to come together to think how to do this, because I don't think there's one single answer there. But the reality is there are probably many different policy levers that could work in this space, and we should be imaginative about this. So I've been told by Pierre, who's the master behind the scenes, that we can have another 5 minutes. So I'm going to pose the question from Luis. I also have a question about critical firms, which we talked about previously, the role of critical firms in this space. But Luis mentioned a very short question with big ramifications: convergence of technologies in a conservative ecosystem. What do you think? I think this whole idea of the combination of many novel technologies, or even a very novel material in a conservative sector. What is your experience there?
Happy to leave the floor to Philippe, and then I have.
Philippe, would you like to have a go?
Yeah, I can have a go. So when I look at that question, the answer and what I saw in the past happening, I call it vertical integration. So basically what's happening there at the end of the day, to be able to win, is basically to master them all, which is almost means own them all. And the example I have is coming again from the photonic space and the semiconductor space. At the beginning of silicon photonics, started many years ago in labs and universities and research and science. But when it really hit the road and it materialized into economical success, it happened with larger organizations that were having a control and taking control of the overall chain, vertically from the product down to the technology and owning them all. So it's something which has the tendency to push toward control. And it was very interesting. We're seeing all of these results, and then Intel came with the first product, having something with a massive $700 million investment, and they made it, and they got it. And that's a bit also, if I go back to the other point, we were talking about the critical firms. This is exactly the same type of answer, basically, because you got at the end of the day, you will end up in the hands of a few, of not many of them. And one other example is that space is with NVIDIA. Look at what's happening around NVIDIA. NVIDIA is not just selling GPUs, CPUs. Now they're having a big stake, a big control on the foundries on one side, and they supply almost turnkey data centers. So these major players will basically have and gain a dominant and critical role, which has to be monitored.
So we're almost at time. I know, Teo, you've got a response, but I'd like to just give each of you, no, but you could use this. I'm going to give you a minute, each of you a minute for final remarks. And you can use that for your answer, Teo, if you like, or something else. What do you think we should take home from the discussion today? I know it's been varied and we're tackling a big issue, but as I mentioned, the insights that you're providing, the tip of the iceberg to today, can really open up new avenues of work for us at the OECD. So please, I'd like to go Teo, Mangala, and then Philippe in that order, and then I'll hand over to David. Teo, you have a minute.
I try to combine the answer and the final thoughts. I think the most important messaging for me is to have these two speeds, parallel speeds in mind. So you have the technologies that evolve very rapidly, but at the same time, they are evolving a more stepwise approach that it might look like from the outside, meaning that the technologies that are really a complete breakthrough, completely different from anything we had before. I don't know, I think at laser, they are very rare. The majority are improvement of an existing technologies, a stepwise improvement that can bring in even just 10 years, an enormous difference in terms of performance, application, and real world impacts. But then having these two parallel two parallel streets, if you want, in mind. On the one side, the impact of these technologies that can improve and accelerate very rapidly based on technological advancements that can be, when you look at the details, the scientific details, a bit more stepwise, because you always found yourself on what it was discovered before you. I think having these two and designing the policies, having in mind the need of these two from market and pure innovation and research perspective, I think is important.
Fantastic.
Hope I was in a minute.
No, you're just under a minute. Perfect. Mangala, please go ahead. A minute or just under, please.
Yes, I think for me, the most important focus or investments in the next years needs to be not funding, promising materials, but really the whole ecosystem around it, which are so that we can repeatedly use it, like the shared infrastructure or shared data structures. And for me, this infrastructure really has to include the skills of the people. So they need to be increasingly comfortable working across disciplines and infrastructure for circularity. And my last point is, I think with all of this materials and all of this discussion on materials and applications, we need to not forget that investment in blue sky research or open research is really important for the next generation of advanced materials.
Excellent. So collaborative platforms, infrastructures, ecosystems that can be the powerhouse for all sorts of incremental improvements in existing materials and novel materials as well.
And blue sky research.
And blue sky research. This is the point
everything,
of
basically everything.
You want everything, Mangala. But why not think big? Philippe, please, you have a minute, and then I'll hand over to David.
Yeah, I agree with Mangala. I mean, countries that focus only on research generate many discoveries. Countries that build infrastructure, foundries, host equipment suppliers, packaging, design, manufacturing expertise, get to a broader scope, will capture far more economic value.
Teo, Mangala, Philippe, thank you very much. Really, thank you very much. I will now hand over to David. It's David.
Thanks, Doug, and thanks to our panelists for a really interesting and insightful and exciting set of thoughts. I think I think we're making already a very good segue into the next panel, which is really focused on policy and drilling into what public policy and corporate policy can do to enable the field, to enable sustainability and so forth. We heard the questions around safety, sustainability, and innovation, and how to design regulation that strikes a balance, and who makes the decisions about how to strike that balance. We heard a little bit about concerns about competition and how certain technologies might be controlled and skew the marketplace. We heard about public trust and the need for policies to promote that. And we heard also the debates around, in terms of support, funding support, going towards research, skills, infrastructure. These are ultimately policy choices, and they will depend on robust policy making institutions. So thanks again to the panel. We will now take a break of, let's say 7 minutes. So you get 2 extra minutes, and we'll start at 3:05. So see you in 7 minutes for the panel 3. Thank you.
Thank you, everybody.
Okay, I'd like to welcome back our participants and a new cast of speakers for this third panel on governance and international cooperation. We've looked at kind of what is happening in terms of tech and its connection to the broader institutional ecosystem and why it matters in sectors. And now we turn to the important discussion of what governments can do to enable these technologies and to enable and optimize social outcomes. I'd like to welcome my colleague Andres Barnecci, who will moderate this panel and who is a colleague on the Global Forum on Technology team. So, Andres.
Thank you, David, and welcome everyone to this panel on policy and governance for advanced materials. My name is Andres Barrenetxe, and I'm an economist and policy analyst, working since the past couple of years in the field of emerging technologies, focusing on quantum technologies. And we had the interesting discussion in the previous panel about how the technological frontier is being pushed further away, thanks to advanced materials, thanks to a new chip that implements a new type of refined material that increases ever slightly so the performance of quantum computers, for example. And this is the case not only for quantum computing, but for many other areas, as we've been hearing on classical computing and semiconductors, biotechnologies, energy. In this session, we will explore the role of government in promoting the development of these advanced materials to achieve these socio-economic applications of the technologies, and while at the same time ensuring responsible innovation. So, for example, advanced materials, they raise questions that we've been hearing about around safety and sustainability across the development cycle. How can we monitor progress in this field? When is standardization and regulation needed, and what types of policy can help foster economic prosperity while managing economic security and risks? What kind of international cooperation is needed? And so we have been seeing that some of these questions have been already emerging in the past panels. And I would like to invite everyone to use the Q&A function and start asking your questions for this panel that we will be considering as the discussion unfolds. And to help us tackle these questions, we are benefiting from the participation of three distinguished experts in this field. We have Iranzu Garmendia, Project Officer at the Advanced Materials Governance Team in the EU Joint Research Center. We have Mar Gonzalez, Administrator of the Program on Nanomaterials and Advanced Materials here at the OECD in the Environment Directorate. And finally, we have Catherine Schwerin, Scientific Employee at the Division on Chemical Safety at the German Environment Agency. So I would like to start the panel with a question around the challenges of policymaking in this field. And so I would like to invite the three of you to give your views on how or why advanced materials are particularly challenging for governments to anticipate, monitor, and manage. And as you answer this question, I would also like to invite you to introduce yourselves, your organizations, and the initiatives that you are leading and in the area of policy and governance for advanced materials. So let me start using the order that we see on the slide with Iranzu.
Good afternoon, everyone. Thank you very much for the introduction, Andres, and I'm very pleased to be part of this panel. So yes, as you said, my name is Irantxu Garmendia, and I come from the European Commission's Joint Research Center. A bit about the JRC, it's the Director General providing independent, evidence-based knowledge and science to support European Union's policies. And the JRC, we are more than 2,000 employees. So I come from the Directorate F, Health and Food, and more specifically for the unit F2 that deals with technologies for health. And within this unit is where I work for the Advanced Materials Governance team. The Advanced Material Governance team especially focus on two main topics that are key for this discussion. One, of course, is the advanced materials, and the other one is the safe and sustainable innovation. In this context, I would like to mention that we are part of the European delegation of the OECD's WPMN, which is what is led by our next speaker, Mar. And within this WPMN, we are as well part of our active in the SIA steering group, that is the Safe and Sustainable Innovation Approach group, and the Advanced Materials Steering Group that is chaired by the other panelist of this panel, Catherine. With regards to what are the challenges, or maybe better to mention the opportunities, we are in this advanced material or advanced materials governance team very much focused on the development and implementation of this safe and sustainable by design concept within the European regulatory and policy framework, while further strengthening the concept and supporting its implementation beyond Europe by collaborating and aligning internationally with the WPMN delegation. With regards to the challenges, of course, as it has been mentioned in the previous panels, it is indeed a challenge, but also opportunity that we are trying to address with this framework that is the safe and sustainable by design, about which I will talk later.
Thank you very much, Irantxu. I would like to then now continue with Mar, please.
Thank you so much for the invitation today, and it has been quite interesting, and I'm really hoping, and I think it's possible that we can give you some of the answers. So I'm Mar Gonzalez, and I lead the OECD work on nanomaterials and advanced materials, which is part or located under the Environment Directorate and part of the Chemicals and Biotechnology Program. And part of, if you want, part of our work really focuses on the environmental health, safety aspects of nanomaterials, and now nano advanced materials, because it's really like the scope of our work. And we really try to develop practical tools that can support regulation and policy implementation across different countries. Okay, so one example is standards, and perhaps we can talk about that later on. So we work closely with regulators, we work closely with policymakers, we work closely with scientists and with industry and SMEs to try to identify common approaches. So this is a multidisciplinary area, and this is something that I would like to emphasize. And part of the work that we do right now at the Working Party on Manufacturing Nanomaterials is really about thinking about, as Irantxu already mentioned, is like a safer and sustainable innovation approach, something that can change the mindset on the way we normally address the management, the safety management of chemicals, but also to think in parallel about advanced materials. What are the new specificities of advanced materials, the functionality, for example, and other aspects that we need to consider. So one challenge, perhaps it's not a challenge. I think now we are used to it, even though we are in apnea most of our time. But we have been working in this environment where we have to provide very actionable solutions to governments in a rapidly evolving field where data is often scarce, is fragmented, and is not harmonized. And this really requires that we combine non-regulatory approaches with regulatory approaches, and we try to find the evidence from different sources that can help us to develop frameworks, strategic approaches, and eventually standards that can make sure that the government is effective, that is adaptable, and is supportive of innovation. So I think this is part of the work that we try to achieve within our program. Thank you.
Thank you very much, Mar. Now let's hear from Catherine.
Yeah, thank you, first of all, for inviting me to speak here at this very interesting panel discussion. So I'm from the German Environment Agency, which is a central environment agency under the head of the German Federal Ministry for Environment. And the mission of the German Environment Agency is the early detection of environmental risk, to assess those and to propose solutions in a timely manner. And for instance, tasks of the German Environment Agency, or shortly the UBA, is the scientific support of the federal government to enforce a broad range of pieces of environmental law, but also to inform the public on environmental protection issues. And UBA is dealing with the environmental implication of nanomaterials, but meanwhile also advanced materials since 2010. And yeah, we're actively involved in closing knowledge gaps on hazard and risk of these materials innovation to try making the environmental risk assessment fit for the materials, but also identify further action needs. And advanced materials are quite interesting for the UBA for two reasons. The one thing is that they provide a technical solution for the transformation towards greater sustainability, like the application for techniques of energy transition, or to have solution for more sustainable processes and products, or digitalization and healthcare, as we already heard today. But on the other hand, for some advanced materials, their inherent properties, but also the way we manufacture, use, or dispose their products can contribute to worsen the major environmental crisis of the climate change, the loss of resources and biodiversity, and could also contribute to environmental pollution, which means that we can expect conflict goals, that these will rise when we apply or want to apply advanced materials for various applications. And therefore, for us, it is important to identify the conflict goals at an early stage and to derive and implement measures in a timely manner. And the challenge we see here is, as Mar already said, there are a lot of information gaps for the agencies about the properties of the advanced materials, their functionalities and potential impacts to the environment, and there are lack of methods on how to assess them properly. And to overcome these issues, we see research as a fundamental point, especially regulatory relevant research to address these gaps. But we also see that the money that is put into safety research is meanwhile nearly neglectable compared to the innovation research. And currently, the German higher authorities responsible for environmental and human health safety, as well as meteorologically, have published a research agenda to making aware about the knowledge gaps and methodology gaps that have to be addressed. But also an important point for us is the international and cooperation, where so the OECD WPMN comes into play, where we can exchange internationally on the issues and to find to also to gain knowledge and expertise, not just with other authorities globally, but also with stakeholders from academia and industry, and also the cooperation between authorities within Germany and Europe is a very important point for us, especially in the view of the initiatives and strategies of the European Commission to foster the innovation in materials. Okay.
Thank you so much, Catherine. I would like to ask a follow-up question to the three of you, if possible, if you could share briefly, because something that comes to mind from the discussion today is that you have different communities that are developing advanced materials, potentially not speaking to each other. You have people developing quantum technologies. You have the people developing semiconductors, the supply chain, biotechnologies, energy. How can we design policies or monitor advanced materials in a cross-cutting way when you have these scientific communities, research and development communities, and potentially also policy communities doing the different, looking at the different technologies that are enabled by advanced materials? If I don't know if someone would like to tackle this question.
So perhaps to start, but then my colleagues, they know, and Catherine knows a lot about very specific nanomaterials. I mean, she has a great knowledge on it. But I think the way we tackle it in the WPMN is that we look at the material, we look at the nanomaterial, and then we are looking what are the different applications that they have, and something that comes to mind that was work that was led by Catherine and her colleagues is nanocarriers, for example. What are the questions that you need to ask yourself if a nanocarrier is used in pharmaceutical, or is used in agriculture, or is used for cosmetic, for example? So you have the same material, but then the question that you will have to ask yourself as you move forward in the production chain, and later on, if you have to think about sustainability, then there are some questions that are going to vary. But there are some questions that might be the same. There might be some answers that might be the same when you go to the material itself. So I think this is one way to make it, I would say, manageable, if you want, from the point of view of implementation. But I let my colleagues correct me.
I can try to give an answer, but I fear I don't have a solution to it. I can just say that as an agency, we face this issue just from the other side of the table. And so, I mean, the reason behind this is maybe so you have the innovators who are very familiar with the materials and how to apply it, and then you have the regulators who are quite familiar with regulation and how to assess the materials. But so we don't have a full overview about what's in the research, what is promising about what is in the research, and what will actually then enter into the market, and for which we then have to be fit for it. So we try to overcome this with getting in contact, in exchange with the innovators as far as possible. But we are also aware that there might be sectors we will not reach because, let's say, I come from the chemical safety area where I work or have exchange with the chemical industry, or some colleagues from me have contact with certain application of chemicals, but maybe not so much in semiconductor industry, or those branches who then apply these semiconductors. But yeah, there are also initiatives underway, for instance, within EU research projects to foster this exchange, but this is still a long way going.
Thank you, Catherine. Iranzu.
I can give it a try, although I don't know whether I understood correctly the question, because I think that, it's the complexity of advanced solutions. It's it's so complex. As I said, that it's a bit difficult to put all the solutions that we are discussing in the same basket, right? We need to make it streamlined or fit for purpose. In this context, for instance, I'm following a bit what Catherine and Mar said. Of course, there are ongoing initiatives, at least in Europe, where we are trying to have some kind of overarching policies in the context of advanced materials or advanced solutions, but this is still under development. Although when we are talking about more fit for purpose or focus innovations, as Mar said, when we have the same technology that it's being developed, but that it integrates different applications and different sectors. This is, for instance, in the context of the Safe and Sustainable by Design framework that we have developed and we are implementing in Europe, what we try to do with what we call the scoping analysis. In the end, innovations can happen for many different reasons, but we need to understand why they are happening, what is the system in which they are happening, not only looking at for instance, the material, if we are talking about a nanomaterial, where we look at the safety and sustainability dimensions, but how as well this is going to interact with other processes, users, receptors, consumers, workers in the life cycle, even the end of life of these products at the end. No, so this is the idea of the framework, is to start early on in the design of these materials to map the ecosystem of the system in which they are going to be somehow used, and we humans and environment is going to be exposed, as well as looking at which sectors, which applications in the end we need to consider. So it's a bit the same approach, although implemented in the European regulatory framework and policy.
Thank you so much, Iranzu. And I would like to continue from here and dig in a bit more deeply into how safety and sustainability can be built into innovation at the early stages of research and development. And you started speaking about this already, but how to avoid answering these questions when the products have already reached the market. So how can, in practice, how can stakeholders take your framework on board and consider these aspects in the research and development stages?
Yeah, indeed. So this is what, as I said before, what in Europe we have been working for the last 5 years since the Chemical Strategy for Sustainability was published. And it is indeed the implementation, let's say, of a safe and sustainable innovation approach. That basically what it means is that we should start considering this safety and sustainability aspect early on in innovation, rather than at the end when we have to comply with regulations. With the aim as well of identifying these challenges that especially advanced materials or advanced solutions bring to the table, like new chemistries, the need of new test methodologies, regulatory gaps, so we can address this early on in the innovation, and then as well faster the scaling up and the deployment. So the idea is that, of course, there is still a need to change the way of thinking, because currently we are still, although we aren't integrating this concept, we are still thinking in the traditional way. So, but the SSBD and the safe and sustainable approach, this is what they are enabling. And we need to consider what are the benefits of implementing this framework, because we were talking before about looking at the sustainability, but not only from the environmental sustainability, also from the socio-economic aspects. That will make these solutions as well economically viable. Also from the regulatory perspective, innovation, it's not regulated. We cannot regulate because we are innovating and trying and committing mistakes and redoing things. But at least if we have a regulatory framework in the horizon, we can as well ensure that these innovations will be somehow future-proof. So we need to start looking at the benefits more than the challenges, and looking at the challenges as opportunities.
Very well said. Thank you, Iranzu. I have also a question for Catherine that is related to this issue of addressing advanced materials in a horizontal way, and what capabilities, evidence, and tools do governments need to make informed decisions about emerging advanced materials?
Yeah, good question. So starting with the goal, what we want to achieve is to benefit from the advanced materials for the transition toward more sustainable society, but on the other hand, to avoid risk for human health and the environment. This means we need to start with approaches like horizon scanning and early awareness approaches to identify signals of concern or knowledge gaps that has to be closed or substantiated. And then, as I come from the chemical safety unit, having a deeper look on this issue, we then need to know which properties of advanced materials will be relevant for risk assessment, and how could strategies look like to make an assessment, and which tools do we need for this. And for instance, here the OECD test guideline plays a crucial role. So we need OECD in regulation, OECD test guidelines that are applicable for proper risk assessment of advanced materials. And not just for us as regulators, but also for the industry to give them proper tools to provide them legal clarity and certainty for the innovation when they have to be compliant with the law when the materials enter the market. And on the other hand, it provides also legal clarity and certainty for the regulators, which then helps them for faster authorization processes. And why OECD is so important here is because then the methods are globally agreed between the authorities and agencies worldwide. And this again also then lowers the trade barriers for the innovators. But one also has to think about this, that this will not come for free, also not for authorities, because this will require personal capacities as well as funding for regulatory research questions needed to develop such assessment approaches and methods.
Thank you, Catherine. Something that comes to mind hearing these past couple of interventions is how some time ago asbestos was seen as a miracle, as a material innovation for fireproofing homes and getting cities to solve that type of problem. And without having an understanding of those consequences that those materials could bring in on people's lives, and the massive implications in terms of the human cost and the economic cost of dealing with that, and throughout the world, and linking with this international aspect. Mar, I would like to hear a bit about how advanced materials are developed, manufactured, and traded around the world, and what are the biggest gaps in international coordination, and what new forms of cooperation are needed in the coming decade. And before you tackle this question, Mar, I would like to invite the audience to ask questions to the panelists using the Q&A function. We have some questions in the bank that have been asked earlier today, and a few others that we have from the OECD Secretariat. But it would be great to hear from the audience and what would you like to ask for the panelists. So please go ahead, Mar.
Yeah, thank you. I think the first thing that I would like to stress is we don't need new. We have the platforms for discussion. So those already exist. We have been dealing with this type of questions, for example, on nanomaterials for the last 2 decades, okay? And the expertise that has been behind all this work on nanomaterials is the same expert, N++, that is now dealing with advanced materials. So the platform exists. I think we have to acknowledge that we have already built significant expertise on how to assess emerging materials and how to address these advanced materials or nano-enabled applications, and to understand that much of the scientific and regulatory knowledge is there. Okay, so today we're not starting like 20 years ago. I think today experts know what are the questions, what they know, what are the unknowns. But then what we need to do is so the big challenge is not to identify the issues that lay ahead, but it's really to strengthen policy implementation to practical tools that can support effective governments. Okay, so I already, Catherine touched upon this, that we have to develop fit for purpose methodologies. We have to be able, governments have to promote data comparability, to foster international alignment, and really create these mechanisms that can help to make an all the evidence that is being generated usable and for decision making. So for me, the international collaboration is and will continue to be important. We have less and less resources to do this. Catherine already mentioned the budget dedicated to EHS is not a luxury. It's something that is actually needed in order to promote innovation. And the example that she gave about OECD test guidelines, so they are standards, but they are critical for innovation because these tools help us to have trust, to rely, to have transparency, and to have confidence in the products and technologies that come over. You mentioned asbestos, but I can mention also DDT. There was a Nobel Prize on DDT, and then we thanks to the evolution of science, we understood that there were already some consequences of it. So I think for me, the greatest challenge today is really to moving from good policy concept to effective implementation. And I can't get tired to mention this, is like legislation and policies without implementation, as good as they are, they're only good advice. So what we need is to have international cooperation that can bridge these gaps, that can provide governments with actionable tools, that they can help us to share the evidence and to learn and develop common approaches that can evolve alongside a rapidly advancing technology. So I think that will be my point of view.
Thank you, Mar. And a follow-up question to that is, I'm wondering if there is some kind of approach similar to how in an airplane crash, there's an investigation and there's trying to be an understanding what went wrong. How can we avoid this to happen again? Has there been a similar process for DDTs, for example, for the different aerosol agents that damage the ozone layer and things like that? Has there been like a type of post-mortem that has led to lessons in this field?
Catherine, you might know better than me, but I think yes. I mean, you mentioned asbestos, and when we were thinking about nanomaterials some 20 years ago, they were thinking, oh my God, these materials is going to be the new asbestos. And so already there were a lot of questions that were on the table, and there were already a lot of thinking in anticipating those potential effects. But yes, I mean, and we don't have to forget that we have a human health effect and we have environmental effects, and that those have very distinct type of questions that need to be tackled.
Of course, there's a lot of testing procedures being put in place, standardization and regulation processes, but at the same time, a typical question that we see in emerging technologies is when is it the right moment to regulate? How can we ensure safety, but at the same time not inhibit innovation? Could any of you speak to this question about the timing and the measures to balance innovation and regulation?
Iranto, should I try and you step in? I guess I will take parts of what you will say. I mean, regulation will step in when the material or the product comes to the market, right? If you just look at the material, I mean, there are also other regulation around on plant safety and so on. But yeah, as an innovator, you should be aware that you can prepare for this market entry step. You can already be aware that if your substance or product will be marketed, there will be a legal obligation you have to be compliant with. And so that means to look at these issues on the safety of your materials and more also on sustainability aspects of your material or your product at early stage will help you for the market entry, and to maybe to put some more money in this early on can help you to reduce money or even market failure at a later stage.
Thank you, Catherine. I think I saw one of you unmute yourselves at least to have a go at this one.
Yeah, I can follow up a bit on what Catherine said, that actually it's what I tried to explain with regards to the safe and sustainable innovation approach or the framework that we have in Europe. That in the end, of course, it is a fact that it has been, I think, mentioned in previous panels, that when we are talking about advanced solutions, there are a lot of unknowns, and that these ones, for instance, cannot be addressed because what we have nowadays in regulations as well, it's based on experience, like asbestos, as you were mentioned. After we saw what happened, then now we proactively try to avoid that, but there are in many cases that we have done reactively approach these problems. What it has good of doing this as early as possible in innovation, and to as well, at least as we have it framed in the European framework, is that it's an iterative process. Where you look at these things as innovation or as information, it's available, and it's, as I mentioned before, a try and you learn from the mistakes and you redo again. And one of the things that it's important is that you recognize uncertainties, that you identify in the process trade-offs, and that you also take the decisions based in these trade-offs, uncertainties, and the decision that needs to be taken in order to progress in the innovation. The good thing is that ideally, all this information, as we are implementing these approaches, should be documented, and also when relevant, discussed with the stakeholders. Multidisciplinarity engagement, it's important among different disciplines, as it was mentioned before. In the previous panel, because we are not expert in all the dimensions, but also multi-stakeholder engagement, as I said before, with the entire life cycle actors, and also this exchange can happen early on with regulators when we identify that there is a challenge that we foresee will need a regulation. So the idea is that we, as much as we can, anticipate, as we said, future problems, and being proactive instead of reactive. Of course, we are talking about innovative solutions, so there might be in the future some problem that we could not foresee, but the framework supports at least in this sense.
Thank you, Iranzu. Mar, you may also have some views on the standards question.
Yeah, just perhaps a couple of points. First, I mean, when do we hit with the regulation? Already, Catherine mentioned, I mean, when you want to go to the market, then you will have to respond to regulation. But from the work that we're doing within the OECD, what we're talking about is non-regulatory approaches. When you don't have all the information, but you start discussing about what are the commonalities, what are the concerns that the policy or regulators are starting to see, and you start to build on this knowledge. And it doesn't mean that it necessarily needs to lead to a new regulation. Nanomaterials 20 years ago, and I come back to the example because they were saying, okay, we need a new legislation for nanomaterials. And no, you have a legislation for chemicals that is perfectly suitable for nanomaterials, but what you need to do is to develop the methods to assess the specificities. So I think this is something that is important to mention, that not everything needs to be regulated. And the other part is that standards are not there, and I think they're not there to impede innovation. On the contrary, because standards are done with the best and the most robust science that is available. They are updated on a regular basis. So there's already an uptake on innovation in the standards, and they're only going to make sure that the products are, you know what you're testing, and then you're just facilitating trade with it. And you're facilitating the production at the large scale. So I think it's something that I would like to emphasize. Not everything needs to be regulated. There are non-regulatory approaches available that exist, and the standards that are there are actually helping innovation in my perspective.
Thank you all. Very comprehensive. So we are approaching the end of this panel. Before we close, I would like to hear from you, perhaps in about 90 seconds or so, what kind of takeaway we can get from today's discussion. You gave a nice 3-point list, Mar, but perhaps looking a bit more broadly about how advances in materials are enabling these technological developments. What are the main messages you would like to government officials, people working in policy and governance to take away?
Okay, so perhaps if I can, this is a plea for governments listening around the globe. Perhaps one of the biggest risks for advanced materials and technologies in general, but we're talking today about advanced materials, is fragmentation of the evidence base. I mean, countries are generating data in different ways, research. There is a lot of research going on, a lot of publication, but we are unable to use this science for the purpose of developing the methodologies. So we really need to, it's really difficult to compare and limiting and to compare the results, which limits the usefulness of all the information that is generated. So for me, we need to start collaboration at that early stage. We need to learn from innovators. We need to learn. They need to learn from regulators. So this dialogue starts at the at the earliest possible way, and within our group, we use it as a trusted environment. But we need to generate useful and comparable data. And when we think about one of the problems with it is, for example, think about artificial intelligence. Everybody talks about artificial intelligence because it offers a significant opportunity, including to accelerate the screening and analysis of a lot of materials. But artificial intelligence can only be effective if it builds on high quality and interoperable data that you can trust. So I think this is, for me, one of the big messages for those out there with a lot of funding to give is really, as Catherine mentioned, is really about funding for research, for regulatory research.
Thank you, Mar. Should we then go to Catherine?
Yeah, thank you. So my 5 take-home messages are: so keeping regulation pace with material innovation is a continuous task. This means this also requires continuous funding for regulatory relevant safety research, but also it means to establish and maintain the capacities of the authorities for issues like horizon scanning, for the development of harmonized methods and appropriate assessment strategies for sound decision-making, leading to a regulatory preparedness of the authority, which again is the cornerstone to facilitate the market access of advanced materials. And last not least, solving these issues and challenges on safety and sustainability is one prerequisite to achieve the aims for a more sustainable competitiveness and resilient industry.
Thank you, Catherine. Thank you very much. Iransu?
Sorry, I couldn't find my mic. Yeah, maybe I would like to take the last word that Bernard mentioned about trust, but not about trust on data, more about trusting stakeholders, because as we mentioned, we are talking about stakeholders from different disciplines, stakeholders from different life cycle stages. We are talking about innovators, we are talking about researchers, we are talking about regulators. So there is a need to build trust among all the stakeholders, and actually this is one of the themes that we are now trying to further develop within the WPMN. Man mentioned already the trust environment, because otherwise I think that the paradigm shift, that means at least the safe and sustainable innovation approach, couldn't make or become a reality if we continue working as we have done in the past, working on silos and not trusting each other. What is paramount if we want to make these innovative solutions stand long in the future.
Thank you so much, Iran. So to wrap up in a nutshell, as we are coming to a close to the event, I'd like to come back to the question that we asked at the beginning of this panel around what is needed for policy and governance. And I think you have raised several important points and answers. One of them that struck me was the need for dialogue across the different communities, across the different applications, technological domains, between the innovators, between the regulators, between the different parts of the life cycle. So dialogues like we're having today, we need more of that, and to dive into the specific questions and build, and this is the second point, the capacity for horizon scanning, for foresight, for anticipating, for building approaches that embed the right questions from the beginning of the development of advanced materials. So I've certainly felt like I've learned a lot from today's discussion. So thank you very much to the three of you for all these sharing all these insights and sharing about the initiatives that you're leading. Before I give it back to David, I would also like to thank Pierre Sarlievre, who has informed this panel, who has shaped the panel and the event and enabled the discussion that has unfolded today. So thank you, Pierre, and back to you, David.
Thanks, Andres, and thanks so much, Mar, Ratsu, and Catherine, for a really interesting panel on regulation and policy in this area. I want to now ask Alessandra Colecchia to the floor. Alessandra is the head of Division of Science and Technology Policy here at the OECD in the Directorate for Science, Technology, and Innovation. She will provide some closing remarks for our event today. Alessandra?
Yeah, thank you, David and Doug and Andres, and good afternoon or good morning or good evening for some of you. So this was a very rich 3 hours dialogue. I hope you enjoyed the conversation as I did, and I hope you learned a little bit more about this exciting scientific and technological field of advanced materials. So as we come to the close of today's first Horizon Scanning Dialogue, I would like to offer just a couple of takeaways and talk about the next steps. So today's conversation have reinforced that advanced materials are much more than a combination of scientific fields or individual technologies. There are multiple potential applications we heard about. Advanced materials are enablers that increasingly underpin innovation across a wide range of strategic sectors. And we heard from the panelists the role they play, in particular in the semiconductor industry, in energy, in healthcare, biotechnologies. There are many much more that we haven't heard about, like space. So we have also heard that innovation in advanced materials is not only about discovering new materials, it's equally about developing new ways to design, manufacture, test, deploy, and recover them. So perhaps an important reflection after today's dialogue is whether advanced materials should be viewed primarily through the lens of individual sectors, or whether they increasingly represent a strategic capability in their own right. This point was raised in the second panel, for example. So many of the issues that we discussed today transcend individual applications and sectors. So questions around shared infrastructures and multidisciplinary skills and supply chain resilience, scale-up, industrial deployment, standards, measurement, sustainability, international cooperation. These are common across many different material classes. So this suggests that there is really the value in considering advanced materials as a cross-cutting policy domain that deserves attention in its own right. So this is an area in which OECD and its Global Forum on Technology can contribute. We bring together governments, researchers, industry, other stakeholders from both member and non-member countries. We can help develop a shared understanding of emerging technologies. We can identify common governance challenges and mechanisms to address them. So for example, and this linking to the discussion in the third panel, we have recently worked on a framework that bridges the gap between innovators and regulatory communities, proposing options to co-design regulatory mechanisms that are agile and enabling while protecting societal values. And also, as at the OECD, we obviously support evidence-based policy dialogue. So all of these and today's event contributes to what we work on at the OECD. And so what is next? So the insights that were shared today will inform the technology brief that the GF Tech team will prepare following the dialogue. One of its central objectives of the technology brief will be to answer questions raised today, such as why should governments care about advanced materials? What are the key policy issues they should begin preparing for? And more broadly, discussions such as today also help shape the OECD Future's work on emerging technologies by identifying the issues that deserve deeper analysis and very important international cooperation. So this is the first of our Horizon Scanning series under the Global Forum of Technology, and we look forward to continue the conversation. And we have already foreseen other 3 dialogues, one on digital twins, one on gene editing, and one on robotics. So we welcome your feedback, both on today's discussion and on how the Global Forum of Technology can continue to support its growing international community. Finally, and before we close, I would like to really thank all the panelists and for sharing their expertise insights, to our moderators, David, Doug, and Andres, and all of you who joined today for your continued interest in this important work of the OECD Global Forum on Technology. And well, you've seen the moderators, David, Doug, and Andres, but as Andres said, there's been a big role played by Pierre. Pierre, you can switch on your camera if you want to share yourself. So thank you for preparing so thoroughly today's dialogue. So thank you once again for the participation, and we're looking forward to continue the conversation with you. And I wish you a very pleasant rest of the day or night. Thank you.
And just to finish and close the event, thank you so much. I also want to mention Pauline Arbel, who has been important in the event. We'll welcome you to future events. I hope you've enjoyed it, and give us feedback. We would certainly welcome it. Thank you so much, and have a great rest of the day or evening or morning. Good night.
Bye-bye.